Our next guest, he's the CMO of Vultr. Please put your hands together and welcome Kevin Cochrane. Come on out, Kevin.
All right. Well, everyone, so excited to be here. I hope you like Morty's. Morty, the name of the bird, Mortimer or Morticia. Could be either, whichever your preference. There's more to be had, obviously, in the expo hall there. I'm Kevin Cochrane, Chief Marketing Officer here at Vultr, and couldn't be more excited to be back here at AI Infra. I was first here at AI Infra with the Vultr team back in September when we excitingly announced our partnership with AMD to take to market their Instinct GPU, the MI300X. And since we announced the MI300X, we are now have also announced the Instinct MI325X. And soon, in June, we'll be announcing even the latest generation of GPUs, so stay tuned for that. But I actually misspoke because actually we've been a long-standing partner for AMD, and that's actually the purpose of this conversation here today. So our partnership with AMD goes back to the origins of, what are we happening here on the slides? There we go. Back to the origins of Vultr when we launched the platform in 2014 to build a new global cloud platform that offers the greatest price to performance for global workloads that you're deploying everywhere around the planet. And here at Vultr, we've scaled the next hypervisor operating in 32 data center regions around the planet, all running AMD EPYC CPUs to support some of the most ambitious, demanding workloads on the planet. Now, we're excited to deepen the partnership with Supermicro and AMD, extending our worldwide footprint of data centers with new AI infrastructure powered by the Instinct platform to help people extend their cloud-native application workloads into a new era of what we call AI native application workloads. This is a 10-year cycle we're on to rebuild the data center footprint, to rebuild the data center architecture, and in turn, rebuild our application architectures, and most importantly, our infrastructure architecture, which is what we want to talk to you about here today. Why is this so topical? Well, we just concluded last week a worldwide survey of over 2,000 C-level executives that were responsible for AI decision-making and asked them a litany of over 150 questions. And the most important thing that stood out is that of these people, 40% were looking to alternative providers of AI infrastructure who specialized in helping them extend their cloud-native applications with new AI infrastructure to put AI at the core of all of their applications. Not only were 40% of these 2,000 C-level executives, which was the global 2,000, mind you, looking at alternative providers, the most critical factors for them is they were looking for freedom, choice, and flexibility to support an architecture that was fungible, that was composable, that allowed them to orchestrate their workloads not only across a variety of different regions, but across a variety of different infrastructure. The most important thing is they always wanted to take advantage of the latest and greatest innovations that were happening in emerging GPU roadmaps. And to this end, one of the most important things was how did they get to the ability to be able to maintain that openness, maintain that flexibility without, unfortunately, spending a lot of CapEx on a new generation of GPU, which only got replaced 12 months later with a newer option. And so what we're here at Vultr, working with AMD and Supermicro, is to work on a 10-year cycle of rebuilding data centers, rebuilding infrastructure to help you all rebuild your application stacks. And this starts with introducing a notion of composability to your infrastructure so you have freedom, choice, and flexibility to always take advantage of the latest generation of GPUs coming from AMD and, very importantly, orchestrate the deployment of those GPUs with AMD CPUs. Now, the opening session here today with Inflection was absolutely amazing because what Inflection really told us was it's time to actually build a platform. And let's build a platform that's a hybrid platform. Let's build a platform that can take advantage of a variety of different infrastructure under the covers and completely abstract that away from developers to make their lives easy so they can accelerate deployment of new inference-enabled applications. That's what we believe every single enterprise needs to do. Every enterprise needs to think about their internal platform. How do they build and architect an internal platform that abstracts the underlying infrastructure away from developers so downstream developers can move fast, partner with the business, and start deploying agents in particular at global scale? It's all about taking a platform engineering approach to your infrastructure, making certain that people can easily self-serve and get access to the infrastructure that they need without any bottlenecks. It's that the definition of what infrastructure is required and how it's deployable can be product managed, pre-packaged with all of the built-in controls and governance that make it safe and effective to build and deploy at global scale. In the cloud-native world, we already have a concept of centralized teams that pre-build application artifacts. This is the core of what currently happens in the cloud-native world. You have centralized teams that build core central microservices that actually build those containerized services that can be used and embedded in all of your downstream apps. We now need to extend that concept to containerized models. You can have a centralized team that's actually doing the training, that's doing the tuning of pre-approved, governed, version-controlled models that are built on known good containerized data sets, so you have provenance and you have built-in compliance, securities, and controls about what data was used, when, in what locale to train your actual models. But it's not just good enough to extend core cloud-native principles to both your data and your AI services. You also need to extend it to the infrastructure, because remember, you're enabling a whole new set of teams that need to spin up not just CPUs, but they need to spin up all the corresponding GPUs, and more importantly, all of the associated networking and storage, which is highly differentiated in the GPU world as well. And this is all very costly. So what you also need to do is make sure that your platform engineering teams, your core architects, also think about infrastructure as code and pre-building templates for what services on the back end in terms of the infrastructure should be spun up by each team for purposes of build, for purposes of test, for purposes of training, and of course for purposes of global production deployment. Because only by pre-building these templates can you enable a true self-service experience to move fast at scale, but with all of the safety, security, and governance at the core. When we talk about composability, this is what we're talking about, which is giving all development teams in your organization the golden path. A composable template that defines all of the infrastructure that needs to get spun up so that they can do what they do best and go in and start coding and building a model and just saying, run. At the end of the day, your data scientists, all of your engineers, they don't want to think about how do I get access to an optimized storage array in Tokyo and Johannesburg and in Sao Paulo to make my application run at scale. They should not think about that. They should focus on the innovation. They should focus on the model. They should focus on the application experience. They should focus on driving the business outcomes that they're seeking to do. And then from the centralized team, they should just pick up a pre-built template that in turn just handles all of the underlying infrastructure at global scale. The composable template, it's a product managed artifact. It's source code managed. It's for your compute. It's for your storage. It's for your networking. It's designed to future-proof all your AI deployments and make sure that you get the cost efficiency. At the same time, you're driving innovation faster than ever before. It's about having a template that can spin up all of your accelerated compute, all of your AMD GPUs anywhere in the world on demand in as little as 10 seconds and auto-scale them and scale them to 0 when there's no inference workloads in that particular locale. But not just spin up your AMD GPU resources, you also have to spin up all of the specialized storage resources to make those GPUs work at scale. Storage for GPUs, storage for inference, is very, very different than storage for your native cloud-native workloads. Accelerated storage, and of course, all of the accelerated networking so that you can have the lightning fast performance of feeding real-time data to your vector stores, supporting your inference workloads with as little latency as possible. It's critical when you're also defining these templates and spinning up all of the specialized resources for your AI workloads, you're remembering that the AI itself is not the experience. The AI is embedded into an experience. You still have a web application that a user is interacting with, a mobile application, a website. There's still some sort of application artifacts as well. So the template is actually accelerating not only the deployment of all of your GPU resources, it's also accelerating all of your core cloud compute resources. And in this turn, this is the real power of AMD, enabling a composable template to spin up all of your CPU and GPU resources, all of the associated storage, networking, to support them, all with the greatest price to performance, the greatest cost efficiency, and of course, the amazing roadmap powered by both AMD and Supermicro. What we like to think about it is this is infrastructure as code meeting source code management. Because with these composable templates, you can literally manage an entire tree of version-controlled entities that define at different points in time what was the infrastructure you had to support different types of AI experiences. You can have, for every new release of ROCm, you can update your application template, test it, harden it, and then provision it to your downstream teams and say, great, the new ROCm 6.2, you're ready to rock. Take the new updated composable template, and now when you roll out your infrastructure, you're taking advantage of the latest and greatest generation of ROCm. Or the MI350 series comes out. Well, take your template, update the template, test the template, and then once you harden it and test it, then roll it out to all your teams and say, great, now you have access to a worldwide fleet of MI350s, and here's all the price to performance advantage you're now going to be able to get. Update your composable template. Don't worry about it, developer. You now have access to the latest generation GPUs in the cloud, and you are ready to rock and roll. Now, it's more than just about taking this platform engineering approach and these composable templates. You've got to think about the overall architecture of your application. And the architecture of application is always going to be a hybrid architecture. You're going to have all of your systems on-prem. You're going to still be collecting your data on-prem. We heard about that in the case of the Intel use case of Inflection. There are still cases where all of the data has to be collected and maintained on-prem. But how do you get that data safely and securely to your GPU clusters in the cloud for purposes of training or tuning a model? And more importantly, how do you stream real-time that same data to support all of your real-time inferencing globally, where you actually have rules around what operational data can go where based on reasons of data residency, locality, governance, and more. So what we believe as well is the integration of direct connects to over 900 data centers all around the planet to ensure that you can maintain the security of your data flows both to your training clusters, which will largely exist in centralized regions, as well as to your distributed inference clusters real-time to support all of your real-time inferencing from your AMD Instinct inference clusters. So critical aspect of this, as we heard with the Inflection case study, is you've got to make sure that you have that abstraction layer, not only for the underlying infrastructure so your developers can move fast using pre-approved templates, but also an abstraction layer across your own data centers and the cloud resources so that you have that integrated data flow that, again, is safe and secure. And lastly, if you look at it all together, we can take a simple example where you're leveraging the full power of Supermicro, AMD, and Vultr to power a real-world use case. You can imagine that you have a healthcare portal, and that healthcare portal is embedded in an agent that can support a clinician or can actually support an actual patient. And in this particular case, the actual portal itself is still running on an AMD EPYC CPU cluster powered by Kubernetes running on Vultr, actually talking to a back-end data store that's serving the actual application artifacts necessary to deliver that experience. But the actual request itself is actually referencing real-time data that's powering a RAG agent on the back end that's dependent upon whether you're the clinician or you're the actual patient. And what's wonderful about this picture is this picture can only be delivered by the integrated stack provided by AMD with their EPYC processors and AMD with their Instinct processors, all running on Supermicro hardware. It's a best-of-breed stack. It's a one-of-a-kind stack. It's the open stack. It's the stack that's going to define the next 10 years of cloud compute and AI infrastructure. And here at Vultr, we couldn't be more proud to partner with AMD Supermicro, and we look forward to handling more boardies in the booth. Thank you.